Hello everyone and welcome back to the channel. In today's video, I am going to be demonstrating how we can do some advanced data analytics in Python, and this video is specially targeted towards Excel analysts and Excel users who want to enhance their data analysis skills or scale up their data analysis skills from Excel to Python. So I'll be covering the same data set as I covered in my previous videos and on the Excel series, and I'll also be showing how we can do the exact same analysis with a very simple lines of code, and I will use this code as a template code so that you can also edit this code and do your data analysis for your data sets. So this is going to be a clearly demonstrable code, and I'm going to explain every single line of code. By the end of the video, you will be having a report of this sort which contains your complete data analysis of your data set, and we'll be covering all the topics like univariate analysis. We can see univariate analysis of numerical variables, of categorical variables. We can see then some bivariate analysis of categorical variables, some bivariate analysis of all the numerical variables, and some multivariate analysis as well. So stick around till the end of the video, and I will be doing this in a multi-part series because there's too much to cover in one single video, and I want everyone to grasp every concept. So I'll be breaking it down into univariate analysis, bivariate analysis, and multivariate analysis. So around a 3 or a 4 part series video. So do stick around for the entire series, and do not forget to subscribe to my channel for the latest of data analytics across Python and Excel. So let's dive right into it, and the purpose of this video is I'm going to be walking through every single line of code. I've typed the code before so that I do not waste time while I am explaining every single line of code, and I'll be explaining this code so that you can use this as a template for your data analysis in your project. I'm assuming that you already have some background or some knowledge of Python for this video. If you do not have, then do take a look at my shorts. I've made very quick 1-minute shorts on my channel which cover a lot of Python techniques and concepts, and I've also made some few other videos of Python which will help you get started, especially with Python and pandas. So let's dive right into it. Even if you do not understand this concept, I'll try to cover as much as I can in this video. So in first, I'm going to import the pandas library, and then from the matplotlib backend module, I'm going to import the PDF pages classes. So generally we have to import everything at the start. It's a good practice, but I'm going to import every package from the place where I need it so that you clearly know what is the use of each package and each class. So I'm going to execute the statement, and the next statement is basically from Google.colab. I'm going to import the drive module. So this is basically because I want to upload all my files from which I want to do data analysis on my Google Drive. I'm using Google Colab for this video, so everyone can follow along with their own Colab, which is free. And also, so we have to upload the files on our Google Drive, and this code helps you connect to the Google Drive. So I'm mounting my my drive, okay, and after that, okay, we'll wait for each code to execute. So in case there's any error, we can trigger and we can solve that. Okay, so while this is executing, let's take a look at this. So this is basically the yes. So the drive is now mounted. So this is the file path. So this is where the file is stored. Content my drive, and under my drive, the name of the data set is emptycast.csv, the same data set that we have used in our Excel series. So I'll just set this variable here. Now I'm using the pd.read csv function. So from the pandas package, I'm using the read csv function, which will read this file into a data frame. So I'll execute that. Okay. And after that, let's take a look at the head. So it will give us the example of the first 5 rows of the data set. So that you can see this is the same data set which we are all familiar with: the model of the car, the miles per gallon, cylinder, displacement, and the other features. And we have seen different types of analysis and also a linear regression model based on the same data set. So you are quite familiar with this data set by now. So it's also a good idea to print the columns, because sometimes the data set is too long and there are many features, say of 200 or 300 features. You may not get all the features in the tabular format, so you can see what features you have here. Then now I'm going to use the Seaborn. I'm going to import the Seaborn packages. If you don't have these packages installed, you can always install them using the pip install command. Okay, and then I'm using from the I'm going to import the matplotlib.pyplot. Again, these two packages are used for plotting and creating your visualizations, because you saw that we are going to create the data analysis with visualizations because they help you analyze your data better, and we'll be saving at each and every step the different reports into the PDF file, so that can be displayed to your end user. So let's execute this. Okay, then the next line of code is going to tell you what are the data types. Okay, so once you load it, the next thing you want to see is what are the data types. So you can see the data types. So generally float and int 64 indicates that it is numerical variables, and object indicates categorical variables. But as we have seen in the data set in the past, we note that some of the numerical variables are actually categorical variables. Okay, I made a video also on the difference between the two and when to consider it to be numerical and categorical, so you can see that on my channel as well. Okay, so this is what we do generally, and if you don't know the domains, for example, you do not know what can be considered as numerical and categorical, you can always run this line of code. So what this line of code does, it uses the dataframe.select dtypes function, and we are including float and integers only. So this we are assigning to the numerical variables, all these columns. Okay, the next line of code is we are including object and category. So these are categorical variables. So when the dtypes is object or category, and we are assigning the columns to the categorical variables. So that is how we do it. Okay, but since we have already analyzed the data set and we are quite familiar, we are as we have seen in my Excel series, we know that some categorical variables here, though they appear as numerical variables, you can see here like cylinder, gear, these are not actually numerical variables because they can be grouped. So we can group the data by the number of, by the cylinders or the gears, and we can do analysis on that. So these are actually categorical variables. You can see MPG, displacement, horsepower, on which we can do numerical computation like standard deviation, mean, or any other operation. These are actually truly numerical variables. So I'm going to divide the numerical, the categorical variables here, cylinder, so I can do my categorical analysis, and then in this code I'm doing a very simple, I'm looping in the df.columns, that is this data. Okay, and if the column is not in the categorical variables, it is not present here, and the column is not equal to the model, because the model also is a text variable, right? So we don't want that. So all the other columns, so we are listing it here out here. So what is not the categorical variables, all the other columns are numerical variables, right? It's quite logical. So we can see here MPG, displacement, horsepower, DRAT, WT, and QSEC, these are numerical variables, and these are the categorical variables. Okay, now here I'm just creating you have seen we have earlier called the PDF pages classes. We have imported that. From that I'm just creating one blank PDF named as analysis_plot. So here this will be using as our blank PDF to save all of the PDF we create at each stage. Now let us go to the main topic of the day, is that we are going to see how we can do univariate analysis today on the numerical and the categorical fields. So let us break this down. This code looks a bit more, but actually it's very, very, very simple code. Okay, and anyone who with the basic knowledge of Python can write this code, and it's very, very easy for Excel developers also to understand. So we are plotting the numerical variable, and the reason I put it in the function is because, as I mentioned, I wanted to make this as a templated code. You can use these functions as reusable code and apply the same code for any other of your data sets to do your data analysis. So let's see. The function name is numerical is plot_numerical_grid, and I'm passing in two parameters, that is the data frame and the columns. Okay, so this is a very generic function. So now the number of plots is the length of the column, meaning how many columns are there. So here we can see there are 1, 2, 3, 4, 5. So 5 categorical variables. Okay, and 1, 2, 3, 4, 5, 6 numerical variables. Okay, so the number of plots will be 6 for numerical variables, because we want one plot for each of the columns, right? And now I decided that I want a 3-column grid, meaning in each row I want 3 plots. So for that you can customize this to how many ever plots you want in each row. I put 3, and then this I'm doing the number of plots plus 2, and this is called a float division in Python. So float division, which will only return the quotient. So let's suppose the number of plots are 3. So I get 3 plus 2 is 5, and the float division with 3 is 3 ones is 1, right? Because the quotient is 1 and 2 is the remainder. So we'll get 1 row, okay, for 3 plots. Similarly here the numerical plots are 1, 2, 3, 4, 5, 6. Okay, so we have 6 plus 2, that is 8, and the float division of that is 2, right? So we'll have 2 rows. Okay, so that makes sense, right? Okay, now I will do the, I'm calling the PLT from the matplotlib. So PLT dot subplots. Okay, and here what I'm saying is I'm only defining how many subplots I want. Okay, so this is the number of rows. So this will print the number of rows, and columns I've already said 3, and the figure size is 18. 18 meaning the width of the total plot is 18, and the length is 6 multiplied by the number of rows. So the length will keep on increasing. If your plots keep on increasing, your length will keep on increasing, but the width will remain the same. Okay. Now I'm doing a very simple iteration. I am using the enumerate function, which will help get the column names and the index. Okay, and all these I've explained in my Python short series. You can take a look at that if in case you are not familiar with that, but these are very simple functions in Python. So I'm calling the enumerate function for the columns, and for each of the index and the column names I'm looping. Okay, and here I'm doing a div mod function. So div mod will do the division as well as the modulus operation. Okay, so this is basically to return the rows and columns for each plot. So 0 0 0, you can substitute the values and see. So for I is equal to 0, if I is 0 here, then the division operation is 0, and the column operation is also, I'm sorry, the modulus operation also is 0. So you will get 0 0. So the first plot will be located at position 0 0. So the second plot will be located if it's I is equal to 1. So you will get div of 1 and 3 is, that is 0 again, and the modulus is 1. So the second plot will be located at 0 1, and third at 0 2. Then the fourth plot will be located as 1 0. So we can get a nice plot, plotting all the plots in a stacked fashion, right? Now this I'm calling a very simple. In Excel you would have to do a lot of work for histogram. So I'm calling the SNS, the Seaborn, I mean from the Seaborn library. I'm just calling the his plot. And here I'm passing which column I want. So the first column here, right? I'm looping. So to every column I'm looping. This is the first column. I've stated current density is true. The number of bins for the histogram. And again, this is the axis. So where I want to place the plot, this is at row 0 and the column. So at row 0, column 0 for the first loop. For the second, it will be row 0, column 1, and so on and so forth. And then for this axis, for row 0, column 0, row 0, column 1, I'm going to set the title, the X label, that is the label of the X axis and the label of the Y axis, right? So X label will be the label of the column name, and Y axis we're just labeling frequency. Again, this part is a very simple code. I'm just looping in so that in case there's any missing plot, right? Suppose then I want to remove that to keep the visualization very neat and clean. And lastly, this is just a tight layout so that it is a very compact layout. And after we do this, we just save the output of the numerical analysis into the save in the PDF pages object.savefig. So this will save it in their PDF report. Now similarly for categorical variables, exactly the same. So you see how simple this code is, exactly what you have done for numerical variables, the same generic code for categorical variables, only one replacement. I have, instead of doing a histogram plot, I am doing a count plot. So this will give me a frequency plot, right? You are familiar with that. So they will give you the frequency plot or the value counts. So and for that, the x-axis I am passing the columns, okay, and the data I am passing the data frame, okay. Again, same thing for where I want to plot it, in which row, which column, okay, very simple. Okay, so now let us see the numerical. I'm just calling the numerical variable. I'm passing this data frame which we initialize on top, and the numerical variables list. So I'm passing this list of numerical variables here, and the data frame which we called on top, right? We got it from here. Okay, so let's see how this generates. Okay, let's execute that. So I executed the function. Now I'll call this. Okay, this will take some time because again it's looping through and doing all the analysis for you, and see it's done actually quite quickly. And ideally I would have to do this manually, but you look at the templated code, right? You can apply this. You can see how customizable to any code or any analysis you want to do with any data set. It will automatically take the numerical variables and generate the histogram for every numerical variable in your data set. So you can see I have a histogram for MPG, displacement, horsepower, DRET, WT, and QSEC. Now you're able to understand, right, what we did here with 0, 1, 0, 2, 0, 3, and also here why we did the div mod operation, right? Okay, yeah, the div mod operation, because we wanted to place the individual plots at 0, 0, 0, 1, 0, 2, 1, 0, 1, 1 and 1, 2 locations, right? And you can see how this is compact and it's nice and neat. Okay, and this shows me the kernel density. So what are the probabilities at this particular value? So we can see this has one peak, this is almost two peaks. Again, this is a long right tail. You can see the trends in the data. So you can see this has like two peaks. Okay, so you can understand the data at a quick sight. Again, you can see the median will be somewhere here, and the mean will be greater here. So you can quickly analyze the data without having to look at the numerical values. And let us plot the categorical value variables. I'm not actually walking through the analysis because this we have covered in detail in our Excel series. If you want to understand how to interpret them, take a look at my Excel series. This video I just want to show that how easy it is for the Excel analyst or Excel developer to scale up the analysis or to speed it up using Python, especially if you want to do analysis on large data sets, say millions of rows, or which has columns of in the order of thousands, right? You do not want to be doing that manually in Excel. You can quickly do that in Python with such a simple code. Now this is your categorical variables. Automatically you can see that again this has looped through automatically and provided a nice neat plot. You can see we have more 8-cylinder cars, we have more cars with having 3 gears, and we have more cars having carburetor, having 4 carburetors and 2 carburetors. So quickly analysis, you can quickly get a fit data. And lastly, let us uncomment this code. So I'm going to save this into the PDF we did. Okay. So if you open your Colab, you can see there's an analysis of plot. You can click here and you can download it, and you will get the same PDF that I showed you at the start of the video. The rest of the code where we are going to do bivariate analysis for numerical and categorical variables I'll be covering in the next part of the series, and then I'll be covering multivariate analysis, and I'll be appending all the charts into a single report which we are doing here. So in the next part of this we will see bivariate analysis, and finally we'll see multivariate analysis all combined into the single report which you saw at the start of the series. I hope you enjoyed this video. If you did, do leave a like and any comment on any other topics you want me to make and what you enjoyed about this video, and do not forget to stay tuned for the later parts of this series. Thank you.